Hey guys, today I'm going to be talking about isotonic, hypertonic, and hypertonic solutions. In biology and chemistry, it's often needed, so I think it's just best to learn it now. Okay, so isotonic solutions, what does it mean? Sometimes we know iso means 1, or it also means equal to. So like iso, let's just say it's defined as equal. So okay, iso equals equal. Okay, no worries. Now we know that iso, since it is equal, that describes all these terms are describing solutions. So all of these are describing solutions, right? So we need to figure it out. Alright, now in ISO, I think you might have already known that if it's equal, then the solute concentration in a solution is equal both inside and outside the cell. So what that means is that suppose I had a beaker. Now in this beaker, I had that cell, sorry for my crummy drawings again, but okay, and I had water, so this is my cell, this is water. Okay, so all the dots that I'm drawing right now are the solute concentration outside. Suppose that solute concentration is 30%. Okay? And now inside, I'll also have these dots, and the concentration will be 30% as well. So 30%. So what that means is that the solute concentration inside the cell is the same as the solute concentration outside the cell. Isotonic is one of the easiest ones, and it should be easy to remember because of the first thing. Iso means equal. Now equal throughout the entire solution. That's all you need to know. Okay, so now we go to the trickier ones. We have hypertonic and hypertonic. So hypotonic and hypertonic. Now, I'm just gonna bring across something that I got off this really good website, and it says basically, it describes hypertonic solutions as the concentration of solute in a solution can be greater than the concentration of solute in cells. The cell in a hypertonic solution is basically this. So a hyper means more than normal, something easy for you to remember, and as I said before, iso over here means same as normal. But anyways, let's get back to hypertonic solutions. Now, the concentration of the solute in a solution can be greater than the concentration of a solute in the cells. So what does that mean? Okay, let me just draw a quick diagram for you. So this is going to be hypertonic. Okay. So it means that the solute in the solution can be greater than the concentration of the solute in the cell. So okay, let's do this. This is my little beaker. This is my water. Okay, this is all the solute concentration outside. Just spamming the hell out of it. Okay. Now suppose this is my cell, and I have this much. Okay, so inside I've got 10%, but outside I've got 90%. Now, I'm talking about solute concentration here, so everything's in respect of solute concentration. Now, if you consider that, outside, the solute concentration is much more than what's inside the cell, therefore it's a hypertonic. Hyper, remember, means more than normal. So outside, the solute concentration is more than normal. Okay, no worries. I hope you understand that, and if not, just reference this. And now we'll move on to the next one. So we have hypotonic. Okay, so hypertonic is when it's less than normal. The concentration of a solute in a solution can be less than the concentration of a solute in cells. This cell is in a hypertonic solution. So now I'm just going to, again, just draw a simple diagram. Once again, I'm really sorry for my crummy drawings, but that's okay, I hope you understand. And this is my cell again. Now, this time, it's the opposite of a hypertonic. So it's going to have a lot of concentration here. So suppose inside the cell I've got 90% solute concentration. And on the outside, I have 10%. Now, you can obviously tell that's hypertonic because it's less than normal. The concentration of solute in the solution can be less than the concentration of solute in cells. So this concentration here on the outside is less than the cell. It's abnormal because it's less than the cell. Whereas in hypertonic, it's more than the cell. That's all you need to know. I'm being dead serious, that's all you need to know. So now, if I told you, describe this to me in the terms of, exterior, something, interior. in respect to the concentration of the solute. Now, what we'd have to do is you just have to simply figure it out. In this one, we're talking about solute concentration, remember? So in hypertonic, it would be exterior has more solute concentration than interior. And in this one, it would be interior has more solute concentration than exterior. Now that's pretty much all you need to know, and I really hope that this video helps you, because I was stuck on this for a long time, and I just really need to look into it to get a better insight. Anyways, until next time, I hope you have good holidays.